Stanislav, and I'm from Department of Geography. I like to introduce you in the problems of natural hazards in mountains. An interesting theme, I think. But first of all, we have natural hazards on the one hand and mountains on the other hand. What is a mountain from a natural hazard point of view? There is now an universal definition of mountains. So I extract some elements, a list of elements that help us to describe mountains. First of all, a mountain is an elevation zone above 100 meters, generally speaking. In another part of the world, we can consider mountain terrestrial surface above 500 meters. So 48% of the worlds can be considered a mountain. Another feature is a special morphology and climate. Steep slopes, first of all, and altitude conduct to delineate some level step with individual landscape. There is a difference between mountains, function of latitude, and it is that to generate some kind of biodiversity and food security, some land use opportunities and constraints, and as a conclusion, highlands, such a mountain, are interconnected with lowlands through often very complex linkage. Natural hazards occur in many parts of the world, and daily with yes, Mr. Sahil Kumar, you have hands up. The problem? No? Okay. Each type of disaster is restricted to certain regions. As you can see in this figure, there is an indication, this figure is an indication of the geographical distribution of a number of major hazards. Earthquakes with orange, volcanoes, point, tropical storms and cyclones. So certain hazards occur in particular regions. You can see earthquakes occur along active tectonic plates margins, and the volcanoes occur along subduction zones, and so on. When we consider the problems of natural hazards, I try to make some 6 small chapters. Terminology, 4 types of natural hazards: avalanches, mass movements, earthquakes, and volcanic eruptions, and the final, disaster risk management. So, when considering all definitions, we use primary 3 terms: hazard, vulnerability, and risk. And by the combination of these 3 terms is the term of disaster. When we talk about disaster, we make a short definition of hazard. Hazard is shortly an extreme phenomenon of different origins, naturals in our case, or man-made, of large intensity, such as earthquake intensity, and limited duration, which can vary from seconds to months, but should be defined in time, occurring at a certain location. You can see the formal map, involving a complex interplay between physical and human systems, and causing loss of lives and threats to public health, as well as physical damage. This is a combination between hazard and vulnerable society. The final product is the risk. And the risk materialize, there is a disaster. So it is important to distinguish between the terms disaster and hazard. A disaster is a function of the risk process. Risk results from the combination of hazards, conditions of vulnerability, and insufficient capacity or measures to reduce the potential negative consequences of risk. But hazards, not only an extreme phenomenon, hazards can include latent conditions that may represent future threats. When the threat becomes a reality, or when it materializes, the risk becomes a disaster. For example, a certain area might be located in a region where earthquakes might occur. There is a certain hazard. There is only risk if within the earthquake hazard area there is a vulnerable society. Without a vulnerable society, the earthquake is a natural process or phenomenon. We need disaster statistics or disaster databases. Data on disaster occurrence, its effect upon people, and its cost to countries or to regions are very important for disaster risk management. So there are now a number of organizations that collect information on disasters at different scales and with different objectives. The main important is the International Disaster Database, EMDAT, from Center for Research on the Epidemiology of Disasters, where disasters have to fulfill certain criteria in order to be included in this database. They have to kill 10 people or more, 100 or more should be affected, and or a declaration of emergency or a call for external assistance. This is, or these are for this database. Data on disaster impacts are also collected by reinsurance companies like Munich Reinsurance. For instance, the Munich Reinsurance database for natural catastrophes, NatCat service, includes more than 23,000 entries on material and human loss events worldwide. But this is only a very general site where disaster information can be obtained. At a local level, disaster data has been collected by an initiative of NGO called LARED, initially in Latin America, but later on expanding also to other regions. They generated a tool called Desinventor, which allows local authorities or communities to collect disaster information. Recently, the Asian Disaster Reduction Center has started a new disaster database called Glide Number. But this database is still very incomplete. We'll start our analyze with the first type of natural hazard, the avalanches. As you can know, you can see an avalanche. There is a rapid flow of snow down a slope. In our case, in mountainous areas, avalanches are the most serious threats to life, properties, and they can be triggered by either natural phenomena. Avalanche is a natural hazard, but the avalanches can be triggered by human activity, winter sports, for example. Avalanches can be classified according to the snow quality. And sometimes the deposit may be a mixture of snow, ice, rocks, and vegetation debris. All avalanches share common elements, a trigger, which causes the sudden rupture of the snowpack, an earthquake, or, for example, winter sports. A starting zone, a slide path, a run-out zone, and the debris deposits, which is the accumulated mass of the snow avalanche. According to their morphology, we can distinguish between slab avalanches, loose avalanches, slush avalanches, and powder avalanches. Generally speaking, causes of avalanche formation can be found within 7 sets of factors: slope inclination, snowpack condition, wind action, slope direction, temperature, weak snow layers, and ground surface condition. Mass movements, the second natural hazard, or landslides, generally speaking, landslides. A landslide is a movement of a mass of rock, earth, or debris down a slope due to gravity. From the type of movement, landslides classification after Vance 1978, there are 5 categories: falls, topples, slides, spreads, and flows. On the other hand, the materials are divided into 2 types: rock and soil. The soil is further subdivided into debris and earth. In this way, a landslide can be described by means of 2 words. The first one describes the material, and the second one, the type of movement: rockfall or debris fall. From the Romanian point of view, the national scale, I select the Romanian model, which is a method of assessment of statistical landslide susceptibility. As you can see, there is a combination of factors, 8 factors, that have led to landslide in the past, and there is a prediction, potential prediction, for landslides in areas with similar conditions. The method assumes that similar conditions that have led to landslide in the past will do so in future. We use a general formula with some indexes like lithology, geomorphology. Geomorphology is the slope. structure, geological structure, hydrology and climate, hydrogeology, seismicity, the forest cover, and the anthropic impact. There is some values introduced in this formula, and is generated a final landslides susceptibility map with 5, or if you want 10 categories. This is for 5 categories, and we can see this area, this mountain area, with very high susceptibility. Earthquakes. An earthquake is a shaking and vibration of the ground. Potential damage in an earthquake can be produced by the following main hazards: ground shaking, ground displacement, tsunami and flooding, landslides, fire, and so on. Earthquakes are strongly linked to the geological forces that build mountains, and seismic hazard associated with an earthquake describes the ground shaking level which can be produced by an earthquake, and the seismic hazard assessment is thus the basic action to assess the actual risk. Earthquake is characterized by their magnitude, seismic energy, and their intensity, the impact, the severity of the impact. 4 basic elements are included in seismic hazard assessment. First, earthquake catalog, catalog of seismicity. Second, earthquake source characterization, the definition of zones with similar seismic behavior. Third, strong seismic ground motion, ground shaking in relation to the distance to the source, hypocenter. And fourth, computation of seismic hazard, calculation of the probability that an earthquake occurs in a given area. You can see seismic hazard map of Romania with a more exposed zone in the western part, because there is a seismogenic zone, Brancianei. Volcanic eruptions. Volcano can be described as openings in the Earth's crust through which molten rock, ash, and gases are emitted. But volcanoes can be active or inactive. We concentrate of that active. We can distinguish into two main types. Explosive volcanoes, which give rise to large explosions, which can partially destroy the volcano and project high columns of rock materials in the atmosphere. And effusive
Dan,
volcanoes,
5 more minutes, please. 5 minutes. Thank you.
Okay. And for monitoring the volcanoes, it is necessary to make some observation, physical or geochemical. And a final analyze, short analyze about disaster risk management. Governments and communities have a shared responsibility to develop an integrated approach in the context of sustainable development. Figure from the left, there is a framework on risk management with the indication of the various indicators. And table from the right, there are some definitions for risk management. Disaster risk management is the systematic processes of using administrative decisions, organization, operational skills, and capacities to implement policies, strategies, and coping capacities of the society and communities. It includes prevention, preparedness, relief or response, and recovery and reconstruction. You can see a risk visualization, some statistical information per regions, for risk curves, maps, WebGIS application, spatial data, and what kind of animation. For risk reduction or mitigation options, we use different strategies: risk avoidance, risk reduction, risk transfer, or risk retention. For risk reduction, for example, there is some structural measures, any physical construction to reduce or avoid possible impacts of hazards, and non-structural measures refer to policies, awareness, knowledge development, and so on. They have some references and website sources. Thank you.
Thank you very much, Professor Dan, for very informative, very rich presentation on the concept of natural hazards and distinguishing it from other concepts like risk, vulnerability, and disasters. Thank you so much.